Hello everyone! In this video, we will travel back to the distant past of the solar system, specifically to the time when it was forming 4.55 billion years ago, when the very first planets were taking shape. You will see numerous protoplanets, proto-dwarf planets, and gas planets in the process of formation, such as Jupiter, Saturn and their proto-satellites, as well as Planet X, Neptune, and Uranus. All of this will be shown using the SpaceEngine planetarium. And before we begin our journey, I should mention that this system was created by a user on Steam, and you can find the link to their system in the description of this video. 4.55 billion years ago, the solar system was still forming. The protoplanetary disk had cooled, and all the outer planets had almost completed their formation. The system is now about 20 million years old. The Sun is growing and getting larger, still in its pre-main sequence stage. And here you can see our star, the Sun in the distant past. Here it says that at this moment it is an orange dwarf, spectral type K1v, with a diameter of 1,530,540 kilometers and a mass exactly equal to one Sun. Number of planets 133. Incredible. And it says the temperature is 4,636 degrees Celsius. In automatic photo mode, the star looks exactly like this. And now guys, take a good look at just how many asteroids and numerous dwarf planets there are present here. All these brightly glowing objects are indeed protoplanets. There are a lot of them. And all these numerous asteroids you see are still part of the protoplanetary disk. It's just cooled down, but there are still a lot of particles. Let me repeat, this system is only 20 million years old. The rocky planets that we know today have not yet fully formed, but instead there are currently 3 prominent super-Earths. Enyo, this particular planet here, also Bellona, located here, and Hermes. These are the planets closest to the Sun, but a truly sad fate awaits them in the future. They will inevitably be destroyed by the immense gravitational pull of Jupiter and the Sun itself. Along with them, in the inner part of our solar system, there are many protoplanets and thousands of smaller planetesimals. Here, as you can see, there is an enormous number of them. Now let's take a look at the nearest fully formed major planets. And the first planet from the Sun is the planet Hermes. This is a fascinating world, extremely hot but only just formed. The temperature here is 3,474 degrees Celsius. Let me show it to you in automatic photo mode. This is how it burns, as if it were on fire. Seriously, the surface is molten. Switching back to HDR. Its diameter is 14,834 kilometers, so it's larger than Earth and its mass is 14% greater than Earth's. And it is tidally locked to its parent star on one side. Let's descend to the surface and see what's going on there. Somewhere in this area, right here on the surface, there's no atmosphere, and we can see the molten surface. And if you turn on the automatic photo mode here, this is how everything looks. If you look at it like this, you can clearly see numerous formed protoplanets and developing planets within this fascinating system, and essentially, the vast protoplanetary disk itself. Well, it certainly appears quite interesting. And this is how the star truly looks from the surface of this protoplanet. The distance to the Sun is clearly shown as 0.38 astronomical units. Now let's fly to the second planet in the system, which is Bellona. This is how it looks. Well, here it's a bit less, let's say, scorching than on the first planet, but the temperature is still enormous. 3,344 degrees Celsius. It is also tidally locked to the Sun. Its diameter is 11,396 kilometers, and its mass is 0.56 times the mass of Earth. These are our scorching airless terras. This is how it looks in automatic photo mode. But it's better to view it in HDR. It's less painful for the eyes. Do you agree, guys? I'm descending to the surface, and there's no atmosphere here either. It's just such an interesting surface, red and white. And again we see this protoplanetary disk and protoplanets, and we can see the star. The distance from this planet to the Sun is 0.60 astronomical units. And let's look at the third main planet. This is Enyo, also a scorching world with a temperature of 3,365 degrees Celsius. Its diameter is already smaller than those planets. It's 8,722 kilometers, and its mass is 0.24 times the mass of Earth. But this planet is no longer tidally locked to the Sun, and the solar day here is almost 22 hours. I'm turning on the automatic photo mode. This is how it looks from all sides. Yes, these are just the newly formed planets. I'm turning HDR back on, and let's descend to the surface. Here we are on the surface. There's no atmosphere here either. We can see the protoplanetary disk, and here's the view of the star. The distance from this planet to the star is 0.88 astronomical units. And behind this planet, there are a lot of protoplanets and planetesimals orbiting. Let's take a look at a few of them. For example, let's fly up to this planet and take a look. Here it says dwarf planet protoplanet 40, a hot airless subterra. Here the mass is quite large, 3.5 times the mass of the Moon, a diameter of 5,273 kilometers, and a temperature of 1,727 degrees Celsius. Well, that makes sense. Next, I'll take a look at something interesting over here. As we can see, there are even double planetary systems here. Let's take a look at it. Wow, look, the second component is quite close here. Alright, let's descend to the surface of this planet right here. And yes, from the surface, this second planet looks absolutely huge in the sky. The distance shows almost 7,000 kilometers. Incredibly close. I've turned on the automatic photo mode. And this is the view we're shown here. There are also some interesting protoplanets here. Let me show you one of them now. It's shaped like an egg. This distinctive shape is primarily due to the extremely fast solar day here, which lasts just 2 hours and 27 minutes. Because of the rapid rotation around its axis, it takes on this egg-like shape. And look guys, here's something else I discovered here. 2 dwarf protoplanets are colliding here. Incredible! Alright, let me speed up the time. Let's see how it looks. Yes, there are lags here because of the large number of objects in this system. Well, it's certainly interesting. It looks as if the planet is sliding along the surface and heating up this part. Yeah, it doesn't look very realistic. But this is just a planetarium, so it doesn't have things like in Universe Sandbox, where you get debris and all that. Still, it's cool to watch that there are collisions like this here. Here, someone just depicted 2 protoplanets colliding. By the way, I also found these 2 objects that are orbiting very close to each other, almost on the verge of colliding or actually colliding. If you speed up time here, you can see them orbiting like this, as if they're touching each other at certain moments. It says here that this is a planetesimal, meaning these 2 objects are planetesimals, so that's what it is. But if something is wrong guys, let me know in the comments. Next, let's move on to the outer solar system. Here, Jupiter and Saturn have recently formed and are still actively cooling down. Their moons are also in the process of forming. They are forming around circumplanetary disks, which are made up of planetesimals and generations of protomoons. At this time, the Galilean moons we know are forming, as well as Saturn's moons, Titan, Rhea, Iapetus, Tethys, Dione, and 2 moons that will later collide to form Hyperion and Chrysalis. So here is Jupiter. Let's approach it first. Here is Jupiter itself, and we can see its 4 largest Galilean moons. These are Io, Europa, Callisto, and Ganymede. We'll take a look at all of them later. And we can also clearly see that there is a kind of prominent protodisk, or perhaps a protoplanetary disk, surrounding Jupiter, with many small asteroids orbiting it. And so, this is precisely how Jupiter looks. That's its distinctive shape. Its average temperature is 1924 degrees Celsius. It's extremely hot. At the moment, its mass here is 0.75 of Jupiter's mass, so it hasn't quite reached its full mass yet. And its diameter here is 252,058 kilometers and some. Let me show it to you in auto mode. Oh, well now, of course, we can take a closer look at the details. It has its own kind of storm here, or maybe this is Jupiter's ancient spot, right? Only, well, it's also red basically, although it's more of an orange color. So in general, this is precisely what Jupiter looked like about 4.55 billion years ago. Now about its many moons. As we can see, it looks like the orbits of 3 moons intersect. Let's take a look from another plane. Yeah, it seems that's the case. The orbits do intersect. As I understand it, that's Io, Europa, and Ganymede whose orbits are intersecting, right? Here's Ganymede, and here's Io. And this orbit here is Europa's orbit. Yes, as you can see, they intersect here. But apparently in the past, they didn't collide, since they're still around at this point in time. Well, let's take a look at all these moons. Let's start with Io. This is how it looks. So hot, with a temperature of 1246 degrees, and such a bright close Jupiter next to it. Switching to automatic photo mode. This is what everything looks like. Let's take a look from this side as well. Well, that's Io for you. Yeah, it's a bit yellowish, just like we're used to seeing it. But let's go down to the surface and take a look. Here I am on the surface of Io, and yes, the rock here is this yellow color. That's what the ground looks like here, roughly speaking. Now let's look up at the sky and see how Jupiter appears. Wow, a majestic gas giant. Now, about Io's characteristics. Its diameter is 3,641 kilometers, and its mass is almost 1.22 times that of the Moon. Switching back to HDR mode. Now let's visit Jupiter's second most famous moon, Europa. This is what it looked like here 4.55 billion years ago. Its average temperature is 1026 degrees Celsius. It has a diameter of 3,121 kilometers, and its mass is 0.65 times that of the Moon. Let's descend to the surface to the daytime side. Here we see that there aren't really any intensely hot areas on the surface itself, as if the surface is already covered in ice. Although it's strange, since the temperature here is very high. And here we already see some cracks. I don't know why it's rendered this way, but that's how it was made in this mod. By the way, as I landed here, it's not even a crack, but some kind of elevation. See? If you look at it this way, as we move higher, it's as if there's some kind of elevated canyon here. Of course, it all looks pretty strange. Now take a look in this direction as well. And as I fly out to this side, there's also a wall here. The shape of this canyon is really odd. Well, it is what it is. So, that's more or less how everything looks on the surface of Europa. The rock here is kind of whiter, I guess, but it still doesn't really look like ice. And here is Jupiter in all its glory. Let's switch to automatic photo mode as well. Magnificent! The next moon is Ganymede. I'm heading over there. Wow, it's so bright and red, glowing beautifully. Switching to automatic photo mode. Alright, this is how it looks. Now, as for its characteristics, it has a diameter of 5,262 kilometers, a mass just over twice that of the moon, and an average temperature of almost 1,100 degrees Celsius. And it also has a very thin atmosphere. And this is how it looks against the backdrop of Jupiter and the Sun. Let's take a look in HDR mode instead. Oh, well, this is how it looks in HDR. I'm descending to the surface of Ganymede. Yeah, my simulation is lagging a bit here, it's glitching. There are a lot of objects in this system, so it's not easy for my computer to process all of this. Well, the main thing is that we can see all of this. Anyway, just look at the magnificent view here. By the way, the exact distance from this particular spot to the star is clearly shown as 4.02 astronomical units, and the very last known moon of Jupiter that we currently know of at this moment is Callisto. And as you can clearly see, it is also quite incredibly hot, with a scorching temperature of almost 1057 degrees Celsius. There's a faint atmosphere made up of the element krypton. It also has a mass of 1.46 times that of the moon, and a diameter of 4,816 kilometers. I've landed on its surface. This is what everything looks like from the surface. Here we can see the protoplanetary disk of our solar system. And here in fact is Jupiter itself. In addition to these four main prominent moons of Jupiter that we just carefully looked at, there are also these other bright luminous objects. Take a closer look. This is the small dwarf moon, Protomoon 1. There are also some other interesting objects here as well. Let me show you a few of them. Let's fly over to this one. And here, as you can see, we have this object which is quite large, with a diameter of 3,253 kilometers and a mass of 0.79 that of the moon. And it's oval shaped, like Haumea, something similar to what we have in our solar system. And this shape is most likely due to its rapid rotation around its axis, although it's not extremely fast but still faster than Jupiter's. It's 7 hours and 12 minutes. Here's another bright glowing object. Let's take a look at Protomoon 4. Let's fly over there. It's also a similar object, kind of egg-shaped, you could say. But this object is even more massive than our moon by 45%. And let's take a look at this object as well. This is Protomoon 5. So they all kind of look similar, all sort of flattened. Although I thought it would be the same here too. But my first impression was misleading. You see, this one has a more rounded shape, although its period is also just 7 hours and 11 minutes. But here the shape isn't all that flattened. Well, anyway, it's clear. It also has a large radius. But as you can see, the orbits of those protosatellites aren't shown at all. Maybe they're just on a collision course with Jupiter. I also read that Jupiter actually absorbed a lot of these protoplanets and gained even more mass because of it.